Today we are going to see the coherent bandwidth. So what is the definition of coherent bandwidth? It is statistical. It is a measure of the range of frequencies. The range of a certain set of frequencies will be available. In that frequency range, the channel will be flat. That is, in that range or in that range of frequencies, the channel will pass all the spectral components with equal gain and linear phase. Suppose if F1 to F1 is a set of frequencies we consider, in those F1 to F1, if all the frequencies are having same gain and same linear phase, means we consider it as a coherent bandwidth. So another definition of coherent bandwidth is the range of frequencies over which the two frequency components will have good relationship in their amplitude. So if F1 and F2 are the two frequencies, means these two frequencies will have good amplitude relationship. Then, depending upon the correlation function, the coherent bandwidth can be defined. So if the correlation, that is a frequency correlation function, is above 0.9, means then the coherent bandwidth is BC is equal to 1 by 50 into sigma tau. This is a standard deviation. Suppose if the correlation function is just 0.5, means then the coherent bandwidth is equal to 1 by 5 sigma tau. Next, Doppler spread. So this Doppler spread or Doppler spectrum is felt when the observer is moving towards the source or when he is moving away from the source. There will be the change in the frequency on the signal that he is receiving. That is called Doppler spread. There is a relationship between the time delay spread and the coherent bandwidth. So these two, the time delay spread and coherent bandwidth, describe the time dispersive nature of the channel. That is how the signals spread in time. That is described by the time delay spread and the coherent bandwidth. So this time delay spread and coherent bandwidth say about the change in time felt by each and every signal. It doesn't say about the motion of the mobile with respect to the base station, or the movement of the base station with respect to the receiver, or by the movement of the object's presence in the channel. So if there is a spatial variation between the source and the receiver, or if there is any movement of the objects, movement of the disturbances or fluctuations present in the channel, means it is not set by the time delay spread and coherent bandwidth. So this Doppler spread and coherence time describe a time varying nature of the channel in a smaller region only. So what is Doppler spread? It is a measure of the range of frequencies in which some broadening of the frequency has occurred. So it is a measure of the spectral broadening caused by the time rate of change of the mobile radio channel. So this Doppler spread and coherent time will say about the time varying nature of the channel. This delay spread and coherent bandwidth will say about the dispersive nature of the channel. This Doppler spread and coherent time is due to the motion of the mobile as well as of the base station, or by the movement of the object in the channel. So how can you define the Doppler spread? It is a measure of the spectral broadening caused by the time rate of change in the mobile radio channel. It can also be defined as a range of frequencies over which the received Doppler spectrum is essentially non-zero. That is, every value is non-zero. It is having some integer value. Consider when a pure sinusoidal signal of some frequency is transmitted, assume as Fc. The received spectrum, called the Doppler spectrum, will have some components, some frequency components in the range Fc plus Fd. This is called the Doppler shift. Fd is called the Doppler shift. So when the receiver is towards the source, means Fc plus Fd will be felt. When he is moving away, Fc minus Fd will be felt. The amount of spectral broadening, it depends upon the velocity of the mobile. So whether he is moving closer or whether he is moving away from the source, and the orientation, that is the theta between the direction of motion of the mobile and the direction of the arrival of the scattered waves. Suppose if the bandwidth of the baseband signal is very large, greater than the Doppler spread, this Doppler spread will not have a significant effect on the signal at the receiver. If the bandwidth of the baseband signal, that is the signal that we are transmitting from the source, is greater than the Doppler spread, means the Doppler spread will not have effect over the signal in the receiver. This channel is called slow fading channel. So the bandwidth of the baseband signal is greater than the Doppler spread, means we say it is called a slow fading channel. Coherence time, it is denoted as Tc. It is a time domain dual of Doppler spread. Doppler spread is denoted by capital B and D. So this coherence time say about the time varying nature of the frequency dispersiveness of the channel in time domain. So in time domain, it is explained by the coherence time. In frequency domain, it is explained by Doppler spread. So these two, Doppler spread and coherence time, are inversely proportional to one another. So Tc is equal to 1 by F. How it can be defined means, it is a statistical measure of the time duration over which the channel impulse response is invariant. That is, the channel impulse response will not change for the duration we have considered. So it implies that the channel response is same over the duration we have considered. So that time is called coherence time. Then it can also be defined as duration of time over which the two received signals will have a good amplitude correlation. That is, amplitude relationship between the two signals within the particular duration will be existing. That is called coherence time. So if the reciprocal of the baseband signal bandwidth is greater or larger than the coherence time of the channel, then the channel will change during the transmission of the baseband message, thus causing distortion at the receiver. If the baseband bandwidth is larger than the coherence time of the channel, then the channel will change during the transmission of the baseband message, thus causing distortion at the receiver. So it can also be explained by using the correlation function. The coherence time is defined as a time over which the time correlation function is above 0.5. Then the coherence time is equal to 9 divided by 16 pi Fm. Fm is the maximum Doppler shift. That is denoted by velocity by lambda. So if there are two signals and they are arriving at a time separation greater than Tc, means they are affected differently by the channel. So the time separation should be within the coherence time. Then only the signal will not be distorted. Otherwise, the signal will be distorted.